Are you ready to become a super productive Solidity developer? In this video, you will learn how to use the Remixd IDE like a pro. Remixd is a free and accessible online IDE for smart contract development. It supports Solidity, but also other languages like Vyper and Circom. You can use Remixd not only for learning and prototyping, but also for coding production smart contracts. In this course, we will cover all the features of Remixd, starting with the basics and then progressing to advanced features such as coding AI in Remixd, working with Hardhat Foundry in Remixd, working with your local file system in Remixd, debugging in Remixd, using Git workflows in Remixd, and much more. This course is sponsored by the Remixd IDE, an Ethereum ecosystem public good. Let's get started. In this video, I will introduce the interface of Remixd. Let's start with a high-level overview of the UI. On the left side, we have the icon panel. Next to the icon panel, you have the side panel, which changes depending on the icon selected. Remixd is a tool composed of many modules or plugins. Most are made by the Remixd team, but some are made by others. The default plugins are present when Remixd loads. The essential default plugins are the File Explorer, the Solidity compiler, Deploy and Run, the Plugin Manager, and the Settings panel. On the top part, you have the main panel with open tabs. In the main panel, you can see the active file. But when you load Remixd for the first time, you will see the home page in a tab in the main panel. And below you have the terminal. The terminal can show you the result of your interactions with the blockchain. And you can also use the terminal to issue some commands. You can adjust the size of the text in the code editor with these two buttons. And for all side panel plugins, except the File Explorer, if you click on this icon, it's going to move the whole sidebar to the other side. At the bottom of Remixd is the status bar and the AI assistant. Next, let's explore in more details the Home tab. The Home tab is what will be opened by default when you first open Remixd. After you open a file, you can get back to the Home tab by clicking here. In the Home tab, you can change the language of Remixd with this drop-down. Here you can see the recent announcements of the Remixd team in the Features section, including a new main panel plugin that is a list of curated videos. Below you can see a list of feature plugins. Here you can search the documentation of Remixd. Here you can quickly start a new project by using some templates. Here you can open a recent workspace. And here you can have a few menus to create a new file or open existing ones. Next, I'm going to explain the Template Explorer. A template is a boilerplate to quickly start a new project. You have templates for ERC20, ERC721, and many other use cases. There are even templates that just contain scripts and no smart contracts. To access the Template Explorer, first go to the File Explorer and click the hamburger menu. Then create a workspace, and on the right, you will see the Template Explorer. You can filter templates by category. You can search templates by name. And you can scroll down to see the list of templates. For each template, you can either use them in a brand new project by clicking here, or you can use them in your current project by clicking here. If you want to start from scratch, you can choose the blank template. If you want to start with some basic Solidity files and scripts, pick the basic template. If you scroll down, you will see a list of ERC20 templates. You have a basic ERC20 template, and you also have more customized ERC20 with mintable function, burnable, and different combinations. And you can keep exploring. There are many other templates available. After you have loaded a Solidity contract and then compile it in the Solidity compiler, you will want to deploy it to a blockchain in the Deploy and Run plugin. At the top of Deploy and Run is the environment where you choose the provider. Providers are how you connect to the blockchain. There are many blockchains you can connect to, like mainnet, testnet, or local development blockchain. And there are also many ways to connect to these blockchains, like MetaMask wallet or blockchain API. So let's explore the different options. For that, let's go to Deploy and Run, click on the environment drop-down, and you will see a list of providers. If you want to configure the list, click on this button. This is the list of all the available providers. The providers that appear in the drop-down have a check mark. To add or remove a provider, just click on it. For example, if you add the Sepolia provider, when you open the environment drop-down again, you will see it. More about deploy and run in another video. Next, I'm going to show you how to see the tutorials of Remixd. Go to the plugin manager, search for LearnETH, activate the plugin, and you will see a new menu in Remixd. Click on it and you will see a list of all the tutorials. For each tutorial, you can expand it to see the full description. To follow a tutorial, click on this icon. You will see the list of lessons for this tutorial. To open a lesson, click here. And now you just have to follow the instructions. You can also access a selection of video tutorials. For this, go to the plugin manager and search for Remixd guides. Activate it and you should see a new tab open. And if you go to this tab, you will see a list of video tutorials. In this video, I will show you a basic workflow when you use Remixd. We will cover writing a smart contract, compiling a smart contract, grabbing the ABI, and deploying a smart contract. First, let's cover how to write a smart contract. In Remixd, projects are organized in workspaces. If you open the File Explorer, you will find the default workspace that has a few example contracts and scripts. If you just want to do a quick task, you can use this workspace. To create a new workspace, click on this icon. You can either create a blank workspace or start from a template. Let's choose the template option. This is the template explorer where you can see a list of templates to choose from. Let's choose the basic template. Now you can see the templates folders and files. The smart contracts are in the contracts folder. And if you open this folder, you will see a couple of example smart contracts like the storage smart contract. This is a basic smart contract to store and retrieve a value. We will use this one for this tutorial. Next, we are going to compile the smart contract. Click on the compiler tab. This will take you to the compiler menu. Make sure you have selected the proper Solidity version. Then click on the compile button. You can also trigger the compilation with a keyboard shortcut or by clicking on this button. The compilation was successful, as you can see with this icon. Now let's introduce some errors. Let's compile again, and now you can see the error icon. If you scroll down, you will see the error message. Let's fix our error. And now if we compile again, the compilation is successful. Beside errors, it's also possible to have warnings. Warnings are improvements that are suggested, but not compulsory. Let's go to our code and we are going to introduce a non-critical error. Now back to our compiler menu, let's make sure we don't hide warnings. Let's compile again, and now if we scroll down, we will see the warning message. Last thing about compilation. If you scroll up, you will see an option to activate auto-compile. With this feature, your smart contract will be compiled automatically after every change. No need to recompile manually. This is highly recommended. It will make your life easier. Next, I will show you how to grab the ABI. The ABI allows you to interact with your smart contract from outside the blockchain. For example, if you use a Web3 library like Ethers.js or Web3.js, you will need the ABI of your smart contracts. Technically, the ABI is a JSON document that describes the interface of your smart contract. And it's created by the Solidity compiler every time you compile your smart contract. To get the ABI, click on the compile button, then click on the ABI button. It will copy the ABI to your clipboard, and after you can paste it anywhere you want, like in your code editor. Next, I will show you how to deploy your smart contract. To deploy a smart contract, go to the Deploy and Run tab. Before deployment, you need to choose the environment. The RemixVM is a local development blockchain. This blockchain runs only on your laptop in your web browser. This is ideal for testing and development. The top option is the latest version of Ethereum. In most cases, this is what you want. If you need to target older versions of Ethereum, you can choose one of the other options for RemixVM. Once you have picked the environment, it's time to deploy. To deploy, you have to click on the Deploy button. After, you should see your smart contract if you scroll down. You can see the address of the smart contract, and you can also see different buttons for each external function. For example, let's call the store function to update the value of our variable. And after, let's call the retrieve function to read the updated value. I just demonstrated how to deploy to a local development blockchain. But it's also possible to deploy to a public network such as mainnet or a public testnet. I'm going to show you how to do this. There are different ways to do this with Remixd, but one of the fastest ways is to use a browser wallet like MetaMask. I have already installed MetaMask. On MetaMask, I have already configured Sepolia, which is a public testnet for Ethereum. I've also already selected the Sepolia network. And finally, I already selected an address with some testnet ether. You can get some testnet ether for free by using a faucet. With this, I'm ready to deploy on Sepolia with MetaMask. Back in Remixd, in the environment, I select the MetaMask option. If this is the first time you use MetaMask with Remixd, you will have to allow Remixd to access MetaMask. Then click on Deploy. This time the deployment will be a bit longer because you deploy on a public network and you need to wait for the transaction to be mined. And after that, you will see your deploy smart contract here. In this video, I will show you how to use the code editor of Remixd. So we are going to start with a high-level overview. The code editor of Remixd is based on the Monaco editor, also used in VS Code. So if you already use VS Code, it will probably look familiar. The code editor provides syntax highlighting for Solidity, the language for smart contracts. But it also supports JavaScript and TypeScript, which is very useful for tests and scripts. Each file is saved in a separate tab. If there are too many tabs, you can scroll horizontally to see the hidden tabs. The code is automatically saved every 5 seconds. This is saved in your local browser, but there is also an option to work with the local file system. More on this in another video. And finally, you can adjust the zoom level with these two buttons. Next, I will focus on compilation, errors, and warnings. To compile a Solidity file, click on this button. Make sure that the correct file is selected, as this will only compile the active file. You can also trigger the compilation with a keyboard shortcut. If you are working on a JavaScript or TypeScript file, when you click the play button, it will run the code and not compile it. If there is a compilation error, you will see a red syntax highlighting. The file will become red in the tab, as well as in the File Explorer. To see the error message, hover on the red syntax highlighting. It's also possible to have warnings, which are non-critical issues. You can ignore warnings, but it's recommended to address them. When you have a warning, you will see a yellow syntax highlighting. And like for errors, you can hover on the warning syntax highlighting to see the warning message. Triggering the compilation manually is a bit tedious, but you can also set up automatic compilation by going in the compiler menu. With autocompile, compilation will be triggered automatically whenever you change the code or when you select another file. While we are in the compile menu, it's useful to know that you can also see the errors and warnings in the menu. If you import a file that has an error, your main file is not going to compile. Finally, if you hover on an error on the file tree, you will see the error message. Next, I'm going to demonstrate the autocomplete feature. When you start to type some code, Remixd will try to guess what you want to type and will show you some suggestions. You can navigate the suggestions with the arrow keys, and to accept one of them, just press enter. If you have errors, the autocomplete might not work fully. So in this case, make sure to fix the errors first before using the autocomplete. Next, I will explain quick fixes. Quick fixes are suggestions made by Remixd to fix small mistakes such as missing license, wrong visibility, or wrong data location. For example, here we are missing the license statement. To apply the quick fix, first you click on the line number and you will see a blue dot and you pick the suggestion you want. Next, I'm going to explain import statements. When you code in Solidity, you often need to import code from other files. With Remixd, you can import code coming from 3 sources: local files, npm packages, and GitHub repo. First, let's cover how to import a local file. Here we have 2 smart contracts, and I want to import this smart contract into this one. All I have to do is to use an import statement and reference the other file. Next, let's see how to import some third-party code through GitHub. Let's say we want to import ERC20 from OpenZeppelin. All we have to do is copy the GitHub URL
including the path to the file that we want to import. And back in Remixd, we paste the URL in our import statement. And now we can use the imported code. The other way to import third-party code is to reference their NPM package if they published it. Taking our example of OpenZeppelin, they do have an NPM package. So in Remixd, we can reference the NPM package, then the path to the file that we want to import. And normally this will mirror the file structure that you have in GitHub.
Please note that if you don't specify a version number, Remixd will import the latest version by default. That's why it's recommended to include the version number. For an NPM import, it will look like this, and for a GitHub import, it will look like this. Last note about importing external code. Beside NPM packages and GitHub, the import statement will accept any HTTPS URL that serves a Solidity file.
Next, I will explain gas estimates in Remixd. When you write your smart contract, you want to make sure that your code spans as little gas as possible. Remixd shows you how much gas a function spans. Every time you make a change to the code, you can see how it impacts the gas cost. This also works for the constructor, but this time you have two estimates. First, there is the estimation creation cost, which is the total cost of creating the smart contract, including the cost of executing the constructor. And after, there is the code deposit cost, which shows you how much it costs to store the code of the smart contract on the blockchain. The bigger your code, the bigger this cost will be. Just to be clear, this gas estimate is a subcomponent of this other gas estimate. Next, let's talk of definitions and references. Let's say that you want to use a function, but you don't remember the function signature. Instead of doing a manual search to find the function definition, you can just right-click on Jump to Definition, and you will navigate to the function definition. This also works with any definition such as variables, modifiers, or smart contracts. If you hover on a definition, this time you will see the comments attached to this definition if they exist. Another interesting feature is references. Let's say you want to know when a function is used. You select the function, you click on Go to References, and it will show you a list of all the places where this function is used as well as where it's defined. If you want to jump to one of these references, you just have to click on it. One click will give you a peek at the code, and a double click will navigate to the reference. Like for Go to Definitions, Go to References works with any definition such as variables, modifiers, or smart contracts. Alright, that's it for this video. In this video, I'm going to introduce Remixd Desktop. Remixd Desktop is the desktop version of the Remixd IDE. Contrary to the web version of Remixd, the desktop version runs on your operating system directly and not in your browser. Those two versions are mostly the same, but there are a few differences like offline mode, access to the local file system, and the built-in terminal. Let's go over these. Before using Remixd Desktop, you need to download it. You will find the download link in the description down below. As you can see, Remixd Desktop is very similar to the online version. You have the menu bar on the left, the contextual menu, the terminal, and the main part where you will see the code. But still, there are a few different features, so let's go over them. First, let's cover offline mode. With offline mode, you can work when you are not connected to the internet. This can be very useful if you are in a place with low or no connectivity at all, such as an airport, a coffee shop, or during an internet outage. Before going offline, you need to make sure that you have downloaded the Solidity compilers that you need. For that, you need to go to the compiler menu and open the drop-down. The green icons show you the compiler versions that you have already downloaded. To download a version that you don't have, you just have to click on it. Reopen the drop-down and you will see a green icon once the download is finished. When you are online, you will see a green icon here. And when you are offline, this will turn into a red icon. And when you are offline, you can keep using Remixd with the compiler versions that are already downloaded. Next, I'm going to show you how to work with the local file system. On the online version of Remixd, your Solidity files are saved in browser storage. The browser storage is not a good place for long-term storage. At any time, it might be deleted because of a browser reset, or even by you who accidentally clear your browser cache. For serious projects, it's better to use other options such as your local file system or pushing to a local repository. The online version of Remixd can work with your local file system, but you need to use a plugin. However, Remixd Desktop can work with your local file system natively, no need to configure anything. Let me show you how. Click on the File Explorer menu, then click on the Open Folder button. Then you select the project folder and click on Open. By the way, it's also possible to create a new folder from here. Then let's create a new Solidity file. Let's put some code in it. Now let's open the terminal on our machine. We can confirm that the file was saved locally. And we can also see that the code was saved.
Next, I'm going to show you how you can quickly bootstrap a new project with templates. When you create a new project, you have to select which template to use. If you don't want any, you just pick blank. But you can also select one of the templates like ERC20. You will have to name the workspace, then pick a folder or create a new one. Contrary to the online version of Remixd, with Remixd Desktop, when you load a template, it's saved on your local file system. And now you can start working on your project. It's also possible to clone a Git project. You just have to give it a URL and it will save it locally in a folder of your choice. Next, I'm going to show you how to work with several instances of Remixd. When you work on several codebase at the same time, it's more convenient to have separate instances of Remixd like in VS Code. Turns out it's possible to do this in Remixd Desktop. You just have to go to the File menu, then click on New Window or Open Folder in New Window.
Next, I'm going to show you how to use the built-in terminal. To open the terminal in Remixd, you just have to click here. Since we already have a project open, the terminal is already in the same folder. This is the same terminal that you use outside of Remixd, and you can use any command. For example, let's see the files inside our folder. You can also use commands specific to a smart contract framework like Hardhat or Foundry.
It's also possible to create other instances of the terminal. You can switch between the different instances. You can delete instances, and finally, you can use different shells like bash, zsh, etc.
Next, I'm going to cover how you can use VS Code and Remixd at the same time. Even though Remixd Desktop is a great tool for smart contract development, VS Code is also very popular. So which one should you choose, Remixd Desktop or VS Code? You can use both at the same time. For example, you can use VS Code to write your code and use Remixd for debugging and testing. Since Remixd Desktop can access your local file system, everything will be in sync.
So for example, here we have the same file open in both windows. If I make a change in VS Code, this is reflected in Remixd. And if I make a change in Remixd, this is reflected in VS Code.
Next, we are going to discuss smart contract deployment. To deploy your smart contract, you have to go to the deploy menu. Like for the online version of Remixd, you have access to a local development blockchain. This is a great option if you are just testing your contract. However, contrary to the online version of Remixd, you don't have access to browser wallets like MetaMask. This makes it a bit harder to deploy to mainnet or to public testnet. But don't worry, there is still a solution. You click on Wallet Connect, then you click on Connect, and you will have the option to connect to a few mobile wallets, including MetaMask. For example, if you want to use MetaMask, you select MetaMask, then you install MetaMask on your mobile. You scan this QR code from your MetaMask on mobile, and after that, you will be able to send a transaction. Another option for deployment is to connect to a node directly, such as Infura or a local chain like Hardhat or Envo. And for that, you have other options in the environment dropdown.
In this video, I will explain how to use the AI tools of Remixd. These tools are very powerful and they will boost your productivity. And since these tools are already embedded in Remixd, there is no need to open a separate browser tab. Everything is at the same place. Very convenient. So make sure to watch this video.
What I will show you is based on the Remixd AI, an AI technology developed by the Remixd team. Remixd AI has many use cases such as explaining an existing code base or generating code. And we are going to cover everything in this video. First, I'm going to show you how to use Remixd AI to explain a whole smart contract. So for the example, this is a token contract with a charity fee that is going to donate some money for each transfer. To use Remixd AI, we will click on the robot icon, and in the console below, you will see an explanation of what this contract does. So let's see what we have here. So we have the structure of the smart contract, the variables, the constructor, the functions, and a summary here. So let's see if this is accurate. So in summary, this contract is a custom ERC20 token with a charity fee feature. Yes, that's correct. Then transfer allows the owner to transfer a specified amount to another address, and it's similar for transfer from. And here the AI understood that both functions apply a charity fee and donate it to the charity address. So it looks pretty good to me. Next, I'm going to show you how to use Remixd AI to explain a part of the code. Sometimes we don't need to understand the whole contract, but we just want to zoom in on a specific part. For this example, I picked the router contract of Uniswap v2, which is a popular decentralized exchange. And I want to understand this function, which is used to make a token swap. So first, you select the portion of the code that you want to understand. Then you right click and you select explain this code. And after, Remixd AI will give you an explanation down below. So let's see this in detail. So here it gives us a general introduction. The Solidity function is part of the Uniswap router and is used to swap tokens in a specific path. And after, we will have more detail. So here we have a description of the different arguments. And after, we have a description of what the function does step by step. For example, here it says it calculates the amount of each token in the past that will be received as a result of the swap using the getAmountsAdd function. The result is stored in the amount array, and we can verify this. And here we can see that this is the case. We call the getAmountsAdd function and we store everything in the amounts array. So this is a very accurate explanation of what the code actually does. Next, I'm going to show you how to better understand compilation errors with Remixd AI. So let's go back to the previous code example where we want to create a token. I'm trying to override a function from OpenZeppelin, but there is a compilation error and I don't understand the error. In this case, you can go to the compilation menu, scroll down, and in the error message, you click here to get more explanation. It's going to send to Remixd AI the compilation error as well as the code of the contract. And with this context, Remixd AI will be able to explain in more details what is going on. And it's also going to show you how to fix the error. So let's copy paste the solution. Now let's compile again. And this time it's working. Next, I'm going to show you how to use Remixd AI to better understand Solidity. In the console, you can ask any questions about Solidity by prefixing it with SolGPT, then your question. For example, how can we override functions in Solidity? And now we have some explanation with some code example. Pretty neat. Next, I'm going to show you how to use Remixd AI for code generation. For those of you who have already used GitHub Copilot, this is very similar. When you want to use this feature, first you need to activate it here. Then you create a comment with 3 forward slashes. Then you describe the code that you want to create. For example, let's ask Remixd AI to redo the transfer function. You press enter. Then Remixd AI will make a suggestion. Then you review the suggestion. And if you accept it, you press tab. And now the code is saved into your file. And you can see that the code generated is pretty close to what I did myself. So it's pretty good. The last feature I want to show you is code suggestion. For this feature to work, you need to activate Remixd AI Copilot. Let's say we need to restrict the access to certain functions in our token. we start to create a modifier for that. Then inside, we press the space key to activate the code suggestion. Remixd AI will make a suggestion based on the code of your contract. So in our case, it's almost correct, except that it thinks that the charity address is the admin. What we really want is a separate admin address. So we need to help Remixd AI by creating an admin address. Now let's try to use the code suggestion again. And this time, this is what we want. And we can accept the suggestion by pressing the tab key. In this video, I will introduce QuickDapp. QuickDapp is a tool to automatically create a front-end UI for smart contracts. This can be very useful if you are doing a quick demo during a hackathon. Let's say we want to build a front-end for this smart contract. The first step is to deploy the smart contract. We will deploy it on a public testnet because QuickDapp requires a public network. Let's open MetaMask and pick the Sepolia network. I already have some Sepolia Ether in my wallet. Let's go back to Remixd and we are going to open the deployment tab. In the environment dropdown, let's select the injected provider. This will deploy the smart contract by using MetaMask. Next, we start the deployment. We validate the transaction with MetaMask. Once the transaction is mined, we will see this box appearing here. And in this box, we will see this icon. That's the link to QuickDapp. Keep in mind that QuickDapp is only accessible if you deploy to a public network. If you use a local network, you will not see this icon. Next, we are going to configure QuickDapp. For that, let's click on this icon. This will open the QuickDapp configuration panel. On the top, you can configure the logo, title, and description of the frontend. On the bottom, you can configure the UI. You will see one box generated for each public or external function. You also have a drag and drop visual editor if you want to rearrange the position of the boxes. You can remove columns by clicking on the X icon, and you can also remove a box if you don't want it. QuickDapp hosts the frontend on a platform called search.sh. You will have to input your login and password for this service. If you don't have an account on search.sh, this will create a new account for you using the email and the password you provided. Search.sh is a free service, so don't be afraid to create an account. Then you can configure the subdomain for the frontend. Then you can share this on social media. If you already verify the contract on Etherscan, tick this box. This will add a link to the source code on Remixd. Then with this option, you can disable the terminal. By default, QuickDapp will show a read-only terminal to give some feedback to users. And you can also choose different themes. Finally, you can click on Deploy. And after, you will see this success message as well as a link to the frontend. Now, anyone can access this URL to interact with your smart contract. So let's click on this link to see how it looks like. First, it's asking us to connect our wallet to the dApp. We have to accept. On the right, we can choose the wallet we want to use. On the top right, we can see the address of the smart contract. On the bottom right, we can see a link to the source code of the smart contract on Remixd. You will only be able to see the source code if you already verify the contract with Etherscan. On the left, we can see the UI to interact with the contract. For example, let's try to read the data variable. It works. And now let's try to modify this value. We will have to confirm this transaction with MetaMask. We wait for the transaction to be mined, and we have this information in the terminal. Next, let's check the new value of the data variable, and we can see that it worked. So in just a few minutes, you deployed a front-end for your smart contract, and you can share it with anyone. Pretty neat. In this video, I will show you how to connect Remixd to your local file system with the Remixd daemon, Remixd. With this feature, you will be able to use the powerful features of Remixd while saving files on your computer. Let's dive in. In Remixd, your work can be stored in 3 locations. In the browser, that's the default. That's good for quick prototyping or learning, but you shouldn't use this for long-term storage because browser storage can be corrupted.
Additionally, it's possible to push files to a GitHub repo. Finally, it's also possible to store files locally on your laptop with Remixd. Remixd creates a bridge between your local computer files and Remix. Any change that you make in Remix will be reflected on your hard drive and vice versa. To get started, you need to install Remixd. Remixd is a daemon process that runs on your computer. It's distributed as an npm package, so first you need to install Node.js. Once Node.js is installed, open your terminal and install Remixd with this command. If you already have Remixd, make sure you have the latest version by uninstalling and reinstalling it. Now that Remixd is installed, let's connect it to a local directory. Navigate to the folder of your computer that you want to share with Remix. For example, we are going to use this folder where I already have a smart contract. Once you are in your project folder, run the following command. The command starts the Remixd service and connects the current folder with Remix. Only this folder will be shared and it will only be readable and writable from remix.ethereum.org. Now let's go to Remix in the web browser. In the File Explorer hamburger menu, select the option Connect to Local File System. Since the Remixd service is already running on your laptop, the Remix IDE will prompt you to connect to your local file system. Click OK to allow the connection. You'll see your local files appear in the Remix File Explorer. Once you've connected, any change that you make in Remix will be reflected in your local file system. For example, let's make some change in the smart contract. Now let's check out the file in our local file system, and we can see that the change has been reflected. Before we go further, it's important to note that Remixd will make your local files in a specific folder accessible to Remix as long as the connection is active. For security reasons, keep Remixd open only when you're actively working with Remix. Also, avoid sharing sensitive files that don't relate to your smart contracts in the folder you connect to Remix. Now let's compile and deploy a contract stored on our local directory. This is exactly the same procedure as with files that are only in Remix. First, you go to the Compile tab and you click on Compile. Then you go to the Deploy tab and you click on Deploy. And that's it. When you're done, it's a good practice to disconnect Remix. Simply go back to your terminal and press Ctrl+C to stop the Remixd server. This will end the connection to your local file system. And that's it. We've covered everything you need to know about using Remixd to link your local file with Remix. This tool makes it easier to work on larger projects stored locally while taking advantage of Remix's powerful smart contract features. In this video, I will show you how to use the Remix debugger. For this demo, we will use this smart contract. It has 3 integer variables and 2 functions that update these variables. Let's compile this contract. We go to the Compile tab and we click on this button. Next, we are going to the Deploy tab. We deploy the smart contract and we execute the foo function. In the terminal, next to each transaction, you can see a debug button. This is how you can trigger the debugger. So let's debug the transaction where we executed the foo function. It's going to open the debugger panel on the left. Here you can see the current function being executed. And here you can see the opcode being executed. This slider allows you to navigate through the transaction execution. For example, if I move the slider, you can see that the opcode changed. Next to some opcodes, there are some line numbers. These correspond to the line number of the Solidity code. Some opcodes don't have line numbers. That's because the Solidity compiler creates some boilerplate code. This is related to the internal of the EVM, and we are not going to delve into this topic, but just be aware that when you are debugging, most likely you will be interested in the opcodes with line numbers next to them. You can also use these buttons to navigate the transaction. There are 2 types of buttons. The step into buttons that step into inner functions, if you happen to call one, and the step over buttons that will skip over function calls and will only stay in the current function. For example, if we use the step into button, we will start in foo, then we will step into bar, then go back to foo. But if we rewind and we use the step over buttons, it will just stay in the foo function and skip bar.
For the next demo, we will use this other smart contract. It has a single integer variable and a function to decrement this variable. Let's compile this contract. Next, we are going to the deploy tab. We deploy the contract. We execute the decrement function. And when I get the value of the counter variable, I'm very surprised to find that it's a huge number instead of -1. So let's use the debugger to find out what happened. In the terminal, let's click on the debug button for this transaction where we call the decrement function. In the debugger, we can inspect the local variables like new counter, and you can also inspect the state variables like counter. At the beginning, new counter is equal to 0, but after this part is executed, it changed to a very large number. And if you keep going, at some point, counter is going to be updated to this very large number. The opcode executed to update counter is ssstore. If you scroll down, you will see the arguments given to ssstore. This is the stack where ssstore will take its argument from. The first stack slot tells ssstore which storage slot to update. Counter is the first variable of the contract, so its storage slot is 0. The next stack slot tells ssstore which value to set the storage slot to. And here you can see that this is a very large value. It's the largest value that can be represented in a uint. What happened here is an underflow. At this line, we try to subtract -1 from 0, but uint cannot be negative. As a result, Solidity wrapped around the range and returned the largest number that can be represented by a uint. For the last demo, I will demonstrate breakpoints. Breakpoints allow you to directly go to a specific point in the execution. This is very useful if you have a complex function, but you are only interested in a specific part. This is the smart contract for this demo. We have some integer variables and a function that updates the value of these variables. Let's compile this contract. Then let's deploy it. Let's execute the full function and let's start the debugger. And we're going to put a breakpoint at this line. Now let's click on this button and it's going to skip to this breakpoint. And you can also go back to a previous breakpoint with this other button. Before we finish this video, I want to show you the rest of the UI of the debugger. If you scroll down, you can see the memory. Here you can see the call data, which tells you which function was called in the transaction and with which argument. And here you can see the global variables like block.timestamp. Now you know how to use the Remixd debugger. In this video, I will show you how to use Remixd with Hardhat and Foundry. The first step is to connect Remixd to our local file system. This is a Hardhat project on our local file system. Let's start Remixd in this folder. Next, in Remixd, let's open the hamburger menu and click on Connect to Local File System. Now we can see our project in Remixd. Next, let's compile the project. First, let's open the smart contract to compile. Then let's go to the compile menu. We will use the compile with Hardhat option. This option will use the configuration file of Hardhat where you can specify the compiler version. Let's do the compilation. And in your local file system, you can see that the compilation artifacts were created. Next, we are going to deploy to a Hardhat network via Remixd. First, let's start a Hardhat network with this command. Next, in Remixd, let's go to the deploy tab. In the environment dropdown, let's select the Hardhat provider. This will connect to our Hardhat network. The addresses that you see here are the addresses provided by the Hardhat network. Let's click on deploy. And now if you look in your Hardhat terminal, you will see the deployment transaction. Next, I will show you how to compile in Hardhat and then deploy from Remixd. For that, let's start from scratch. First, we clear the deployed smart contract. Then in the File Explorer, we delete the compilation artifacts of Remixd. After, let's go to our terminal. And we are going to compile with Hardhat. Now, let's go back in Remixd. Let's go to the Deploy tab. And here we see the Compile by Hardhat label above the contract. We click on Deploy and we see our contract below. Next, I will show you how to use console log. In the code editor, let's import the console log library from Hardhat. Let's print this variable and let's recompile the contract. Next, let's redeploy the contract. We go to the Deploy tab, we choose the RemixVM, we click on Deploy, we execute the function where the console log is executed, and we can see the output in the Remix terminal. It's also possible to use Foundry with Remix. The workflow is exactly the same, there's just a small difference in the compilation. In the Solidity compiler, in the advanced configuration, you will have to select the Use Configuration File option. Remix will add a remapping key to this file. Copy over your remappings from Foundry, if any. Now you know how to use Hardhat and Foundry with Remix. In this video, I will show you how to import dependencies in Remix. First, I will show you how to import a dependency hosted on GitHub. Let's say you want to import the ERC20 contract from the OpenZeppelin library. In Remix, you can reference the GitHub URL after the import statement. And now you can reference the imported symbols. It's recommended to import a specific version, otherwise you will get the latest version of the master branch. To import a specific version, in the import URL, replace master by the version that you want. Next, I will show you how to import a dependency hosted on NPM. Let's take the example of the ERC20 contract from OpenZeppelin. In Remix, you can reference the NPM URL after the import statement. And now you can reference all the imported symbols. And once again, it's recommended to import a specific version. Now you know how to import dependencies in Remix. In this video, I will show you how to use LearnETH. LearnETH is a plugin for interactive tutorials. You can use it to learn smart contract programming and also to learn how to use Remix. To use LearnETH, you have to activate its plugin. Go to the plugin menu, search for LearnETH, and click on Activate. If this is the first time you use LearnETH, you may see a modal window asking you permission to write a file. Click Yes, and also remember this choice. When you go to the LearnETH plugin, you will see this menu. If you click here, LearnETH will switch to the other side of the screen. If you do this, LearnETH will reinitialize, and so if you are in the middle of a tutorial, you'll lose your place. Here you can see the list of courses. You have courses for beginner, intermediate, and advanced levels. You have one course for learning how to use Remix, and the rest of the courses are about smart contract programming and blockchain. First, let's try out this Solidity course. If you click here, you will see a longer description for the course. And if you click here, it will start the course. This is the list of lessons. Let's click on this one. On the top left, you have the menu bar. To go back to the home menu, click here. To see the list of lessons, click here. To navigate between lessons, click here or here. On the left, you have the lesson and challenge description. And on the right, you have the code of the current lesson. At the bottom of the left panel, you have a button to check your answer and another to see the answer if you are stuck. Let's solve this challenge. Let's check the answer, and this is correct. Next, let's check out the NFT course. We go to the homepage, we click on NFT course. This course will go through the Solidity code of an NFT contract and then show you how to deploy a contract that has a graphic digital asset attached to it. And we start with this lesson. In this lesson, there is a quiz. You have to write the answer number in the Solidity file on the right. For example, let's try. Then let's check the answer. I have 2 errors. And if I want to see the answer, I click here. Next, let's check out the NFT auction course. We go to the homepage, we click on the NFT auction course, and we start with this lesson. This tutorial goes over the Solidity code of an NFT auction contract, and then it shows how to interact with it. And here you will see another type of assignment. You have to do a series of tasks, and when you are done, you click on Next. But unlike the other courses I showed you before, there is no feedback mechanism. The great thing about having a tutorial inside of Remix is that you can work on a lesson, but then veer off to try using Remix other tools on the example files, like the debugger or Solidity static analyzers, to learn even more. With these tutorials, your understanding of Solidity should improve through practical application. Now you know how to use LearnETH in Remix. There are many other courses available and I encourage you to explore them.
In this video, I will explain the RemixVM and forking. First, I will show you how to save the state of the blockchain. For this tutorial, we will use this simple smart contract. Let's go to the Deploy tab. Let's open the Environment dropdown. Let's click on Customize, and we are going to add an older version of Ethereum called Shanghai. Now we select this version. Let's deploy this contract, and let's modify the state of the contract. For example, let's call the store function with 10. So now the value of the number variable is equal to 10. If you go back to the File Explorer, you will notice that we now have a folder called .states. This folder stores the state of each local blockchain where you have a deployment. For example, we can see a folder with the Shanghai VM and a JSON file that stores the state of this blockchain. If you want to persist this state or share it with other people, you can push this workspace to an external repo. Later, you can pull this repo and you will be able to work from the state that you saved. For more information on how to save a workspace to a repo or load a workspace from a repo, check out our video on Git in Remix. Next, I'm going to show you how to fork the RemixVM. This is useful if you want to easily switch between different blockchain states using the RemixVM. Let's go to the Deploy tab. And just above the Environment dropdown, you will find an icon to fork the chain currently selected. Currently, the RemixVM is selected. So if we click here, it will create a fork of the RemixVM. Any state change that we do for this blockchain will be isolated from the original RemixVM. And it's also possible to reset the state of the blockchain if you click here. Once you have created this fork, it will appear in the list of environments. And if you want to remove the fork from this list, you can click on Customize this list, then click here. And it's also possible to delete this environment. Next, I'm going to show you how to fork mainnet on Remix. Forking mainnet is very useful if you want to test your contract against production data, or in other words, the state of mainnet. We are going to deploy this smart contract to our mainnet fork. In this smart contract, we first define a pointer to the USDC smart contract. Then we define a function where we return the USDC balance of an address. Let's deploy this contract on a local mainnet fork. For this, let's go to the Deploy tab. Let's open the Environment dropdown. We click on Customize. And let's enable the mainnet fork so that we can select it in the dropdown. Now we can see it in the dropdown. Let's select this option. Now let's deploy the contract to our fork, and then let's execute the USDC balance function. This is the address of the top holder of USDC at the time of recording this video. Let's execute the function, and we see the actual balance of this address on mainnet. This is working. Now you know all about the RemixVM and forking. In this video, I will show you how to run scripts in Remix. Scripts allow you to code deployments and interactions with smart contracts. The main advantages of using scripts is to have a repeatable process that is both safer and faster. This is especially useful for complex deployments. To demonstrate scripts, we will use this smart contract available in the default workspace. This is a simple smart contract with an integer variable, a function to update the variable, and a function to read the variable. In the default workspace, there are also some example scripts. Let's check out this one. Scripts are written in JavaScript or TypeScript and saved with the extension JS or TS. Scripts need to be wrapped in an asynchronous self-executing function. Scripts can use the Web3 or Ethers libraries. This script uses a utility function defined in another file. This utility function allows to deploy smart contracts. In this line, we deploy the storage smart contract. And in this line, we console log its address. To run a script, there are 4 options. You can click on the play button. You can right-click on the script file and click on Run. You can execute the script in the terminal with this statement. Make sure that the script is the active tab. And finally, you can also use the Compile and Run button in the compiler menu. This will let you set the state of the contract right after compiling, which can be a big time saver. For this to work, you will need to add a comment in your smart contract where you specify which script to run. So let's do a demo. In the terminal, you can see the script execution, including the console log of the contract address. And now if we go to the deploy tab, we can see that the contract was indeed deployed. And we can expand this box and interact with our contract as if we deployed it manually. Next, let's create a custom script. First, let's create a new JavaScript file in the scripts folder. Next, let's create an asynchronous self-invoking function. Next, we need to deploy the smart contract. For this, we will use the deploy function defined in this library. This is a library that is provided by Remixd. Then we can call the deploy function with the name of the contract and store the contract object in a variable. Then we can execute the store function. We first send a transaction, then we wait for it to be mined. And finally, we can execute the retrieve function, which will return the updated value of the variable we just changed. And we console log the result. Our script is ready, and next we will execute it. In the terminal, we can see that the updated value of our variable is 10 as expected. So next, I would like to demonstrate a slightly more advanced script. So let's add another function to our smart contract. We define a new variable, a new setter function, and a new getter function. And now let's go back to our script and let's add some code to set the value of the second variable. And let's also console log the result. And this time, to execute the script, we will hit the compile and run button. So first, let's go to the smart contract and let's update this command to reference our script. Then we go to the compile tab, we click on compile and run, and we can see the script execution in the terminal. You can see how convenient it is. No need to click on all the buttons of the function to set the state. You just have to run the script. As a side note, be aware that instead of creating a script from scratch, you can also customize some of the example scripts provided by Remixd. In this video, I will show you how to use Git in Remixd. Git functionality is mainly in the Git plugin, but some features are integrated in the File Explorer. Pushing your work to a remote repo in Remixd is important so that you are not totally dependent on the browser storage to save your work. For this tutorial, we will clone this GitHub repo. It has a single file, a simple storage smart contract. This smart contract has an integer variable, a function to update it, and a function to read it. Back in Remixd, we are going to clone this repo by clicking on the hamburger menu, then clone. Then we input the URL of the repo. And now you can see the repo in Remixd. It has created a new workspace. And next to the name of the workspace, you can see the Git logo that indicates that it's a Git repo. Next, let's make a change. We are going to make this variable public and remove this function. Next, let's go to the Git plugin and let's open the GitHub setup menu. Log into GitHub, and after you should see these new menus. Let's open the source control menu. And you can see the list of files that were changed since the last commit. You can add all modified files to the staging tree with this button, or you can add files individually. Let's inspect the changes. We click on the file name, and on the right, you can see a Git diff. Once you are happy with the changes, it's time to add your file to the staging area. So let's add the smart contract file. Next, let's type a commit message. Let's click on commit, and finally, let's push to the remote repo. To push, you can click on this button. Now, if you want to see a list of commits, you can open this other menu. We can see the initial commit and the commit we just pushed. Next, I will show you how to do some more operations. For more control on push-pull operations, you can open this menu. You can select the local and remote branch, and you can even do a force push. If you need to do some operation with branches, you can open this menu. You can create a new branch, pull remote branches, and you can also switch between different branches by clicking here. Branch management can also be done at the bottom of the File Explorer. For example, let's create a new branch. And now let's switch branch.
Finally, if you need to add other remotes, you can use this menu. At any time, you can see the active branch here in the status bar. Now you know how to use Git in Remixd. In this video, I will show you the different ways to open files in Remixd. First, I will show you how to clone a GitHub repo. Go to the File Explorer. Click on the hamburger menu. Click on the Clone button. Enter the URL of the repository to clone. Click OK, and it's going to open the whole repo in a new workspace. It's also possible to import a whole GitHub folder by adding this parameter in the Remixd URL, followed by the URL of a GitHub folder. It will also create a new workspace, but this one will be temporary. Next, I will show you how to import files from any website. This will work for any website as long as it's on HTTPS. For example, let's import the file of the ERC20 contract of OpenZeppelin. On the GitHub page, you click on Raw, then you copy the URL. Back in Remixd, you click on the Import File with HTTPS icon. You paste the URL, and now you can see the file open in Remixd. It's also possible to load a file from any HTTPS website with the URL. You have to add this parameter at the end of the Remixd URL, followed by the URL of the file. Next, I will show you how to open a GIST. In the Home tab, click on this button and enter the GIST ID or the URL to the GIST. It will open the file in a new workspace. Next, I will show you how to open a verified contract. Smart contracts often interact with other smart contracts. That's why it's useful to open files of production smart contracts that are deployed to public chains. In Remixd, you can open the verified smart contracts from Etherscan and other blockchain explorers. Go to the plugin menu, search for the contract verification plugin, activate it, go to the verification plugin tab, go to the lookup menu, select the chain of the contract, input the address of the contract, click on lookup. Remixd will show you the corresponding verified contracts found in major blockchain explorers. Note that for Etherscan, you will need to configure your API keys first in the Settings tab of the Contract Verification plugin. Then, click on this button to open the source code in Remixd. Next, I'm going to show you how to open a contract from cookbook.dev. Cookbook.dev is a collection of popular smart contracts such as DeFi protocols or libraries. You can open smart contracts of Cookbook in Remixd. First, go to the plugin menu, search for the Cookbook plugin, and activate it. Next, go to the Cookbook plugin, search for a smart contract, and click on it. It will open a new tab with the source code of this contract. There are many other ways of opening files in Remixd, such as using a workspace template. This is already explained in the Intro to Remixd video. Remixd, which allows you to open a file or folder stored on your computer hard drive, and this is already explained in the Remixd video. Okay, so now you know all the different ways to open files in Remixd. In this video, I will show you how to deploy smart contracts and interact with them. We are going to deploy this smart contract. This is just an example smart contract. We just care about the function interfaces. First, we need to compile the smart contract. So let's go to the Compile tab and hit the Compile button. Next, we need to run the deployment. We go to the Deploy tab. And for this example, I will select the local development blockchain of Remixd, but you can also select public networks. We click on Deploy, then we scroll down, and we will see the deployed contract. To interact with the smart contract, you need to expand this box. For each public or external function, you will see a corresponding button. The orange buttons are for the non-view functions, where you can send a transaction and modify the state of the blockchain. The red buttons are for the payable functions, where you can send Ether. And the blue buttons are the view and the pure functions, where you just read data from the blockchain. So let's do a quick demo. First, let's execute the non-view function. We need to provide an array of integer. We use a comma to separate the arguments, and we wrap everything in square brackets. As a side note, this notation will also work for tuples and structs. We click on this button to execute the transaction, and after you can see the transaction receipt in the console. Next, let's execute the payable function. We have a lot of arguments, and it's not really convenient to cram everything in a small input. That's why it's better to expand the input field with this dropdown. We put all the arguments. Next, we need to specify how much ether we want to send. Let's scroll up, and here you can see the value field for ether transfers. Let's change the unit to ether, and let's send 1 ether. Next, we scroll down, and we execute the function. Now our transaction is complete. Next, let's execute this view function, and we see the return string just below. Next, I will show you how to use the low-level interaction feature. Low-level interactions allow you to create the data field of the transaction manually and also to interact with the fallback or receive function of a smart contract. For example, let's call the receive function by sending some ether to the smart contract. We will leave the data field empty. If you want to send some data in your transaction, you will need to build your data argument yourself and paste here, then click on transact. Next, we specify how much ether to send. For that, we scroll up to the value field and we input the ether value here. Before sending this transaction, be aware that you have to respect the rules about fallback and receive functions. If you don't, Remixd will give you a warning. Next, we scroll down to the low-level transaction button and we click on it. And that's it, our transaction was sent. Next, I will show you how to interact with the smart contract that is already deployed. For this example, we will interact with this smart contract deployed on Sepolia. You will need the ABI or the source code with the same compiler settings. Let's copy the ABI from Etherscan. Back in Remixd, let's create a new file with the extension ABI, and we paste the ABI inside. Make sure this file is the active tab in the editor. Next, we need the address of the contract, and we can get it from Etherscan. Back in Remixd, we go to the deploy tab, we find the @address input, and we paste the address inside. Next, let's make sure we are connected to the correct blockchain. Our smart contract is on Sepolia, and we will connect to Sepolia using MetaMask. So in MetaMask, I already selected the Sepolia network. In Remixd, in the environment dropdown, we need to select MetaMask. You should see the chain ID just below the environment select box. Then click the @address button and the contract will appear in the deployed contract section. And now if you expand this box, you can interact with the smart contract as I showed you before. Remember that you need to have the ABI or the compile contract to be in the active file in the editor to use this feature. Next, I'm going to show you the pinning feature. Pinning lets you access a contract without having to remember its address or locate its ABI. In the deploy contract section, just click on the pin, and the next time you connect to that network and use the same workspace, the pin contract will be present. This works for all networks, including the RemixVM. In this video, I will show you how to use Circom in Remixd. For this demo, we will use a template project provided by Remixd. Go to the hamburger menu, click on Create Using Template, search for Circom, and we will use this project. This is our Circom circuit. It's a simple circuit that makes sure that a variable is the product of two other variables. When you download a Circom template, it automatically activates the Circom plugin. Alternatively, you can also activate the plugin yourself in the plugin manager. Let's go to the Circom plugin. You can choose the compilation target. You can activate autocompile, and you can also compile manually. So let's click on compile. The next step is to run the setup. First, you have to choose the proving scheme. Then you have to choose the p-tau. Choose the lowest number of constraints that will work with your circuit. If you choose a p-tau that is too small for your circuit, the setup will fail. Similarly, if you choose a p-tau that is too large for your circuit, the setup will also fail. If you tick the options Export the verifier Solidity contract and the verification key, a pop-up toaster will show the location of these files. Then click on Run the setup. if everything went okay, you will see a green check mark here. Then you need to compute the witness. You provide the inputs here, then click on compute. You should see a green check mark here if it went well. And finally, click on generate proof. The proof will be generated, and if you've exported the verifier call data, it will be put in a JSON file and a pop-up toaster will show its location. In the terminal, you can see the confirmation that the proof was successfully generated. Once the proof has been generated, you can submit it to the verifier contract. For that, you will need to compile and deploy this Solidity smart contract. Then you will need to execute the verify proof function with the content of verifier call data.json as an argument. As a first side note, if you scroll up to the top of the plugin, there is an optional advanced configuration where you can choose the prime numbers to use. As a second side note, it's also possible to run Circom operations with scripts instead of the GUI. And you can check out the scripts folder of the Circom templates for some script examples. Now you know how to use Circom in Remixd. In this video, I will show you how to use proxy smart contracts in Remixd. One of the most popular standards for proxy smart contracts is UUPS. For this demo, we will use a UUPS template provided by Remixd. In the hamburger menu of the File Explorer, we go to Create Using Template. Then we search for UUPS templates. We are going to select the first one, which is an upgradable ERC20 token. This is the code of our upgradable token. Next, let's deploy our contract. We go to the Deploy tab. Below the Deploy button, you have additional checkboxes. Remixd detected that this is an upgradable contract and offers us some extra options. We select Deploy with Proxy. And we'll have to provide the argument for the initialize function. Then we click on Deploy. We approve the two dialogues. This will send two transactions, the deployment of the token, the deployment of the proxy. In this demo, we use the RemixVM and the transactions appear to be instantaneous. But if you did this on a public blockchain, you would need to wait for each transaction to be mined before approving the next one. Below, you can see two contracts. First, we have our token contract. Then we have our proxy contract. To interact with our token contract, you have to use the interface of the proxy. For example, let's read the name of the token, and this is correct. Next, let's upgrade the token. We are going to create a new implementation. Let's go back to the File Explorer. Let's create a new file. This is our new implementation. We have one extra function to return the version of the token. Now let's go back to the Deploy tab. Let's clear the deploy contracts here. This is just at the UI level. It doesn't do anything to the state of the blockchain. Next, we will do the upgrade. We will select the Upgrade with Proxy option. We need to input the address of the proxy. We click on Deploy. We approve the two dialogues. This will send two transactions, the deployment of the new token and the configuration of the proxy where we update the address of the token. Below, we can see the new token. We can see the new version function. And if we click on it, we get the expected output. As a side note, be aware that it's possible to verify proxy smart contracts with the verification plugin. Please refer to the video about contract verification. Now you know how to use upgradable smart contracts in Remixd. In this video, I will show you how to use smart contract languages other than Solidity in Remixd. First, let's focus on Vyper. We are going to create a Vyper smart contract. Let's go to the File Explorer and let's create a file with the VY extension. This is the extension for Vyper files. Then I'm going to put my Vyper code in the code editor. Next, it's time to compile the smart contract. To compile a Vyper smart contract, you can click on the play button or you can use the Ctrl+S shortcut. By default, the Vyper compiler will remotely compile the contracts. It's also possible to compile Vyper locally, but you will need to connect Remixd to a folder on your file system with Remixd, and you will also need to have a Docker container that runs the ape framework. To learn how to use Remixd, please watch the other video on this topic. The compilation will activate the Vyper plugin if it wasn't already activated. This is the Vyper plugin. You can also trigger the compilation with this button. If you see this green check mark, it means the compilation was successful. Now let's introduce an error, and let's compile again, and you will see the error below. Click the error card to get to the corresponding line in the editor. Let's fix our error. Let's compile again. Next, let's go to the Deploy tab. We select the right contract. We click on Deploy. Then you can see the deploy contract below. And you can interact with it by using buttons. It's the same workflow as for a Solidity smart contract. As a side note, in the Vyper compiler, if you click here, you will download some examples of Vyper smart contracts in Remixd. Remixd will get this repo and create a new workspace in the file explorer called Vyper. It's a fairly large repo, so it can take some time to load. Beside Vyper, it's also possible to use other smart contract languages such as Rust by using the Arbitrum stylus plugin, Cairo by using the StarkNet plugin, and there are plugins for other chains that run Solidity but need a specialized compiler. For example, you can take a look at the zkSync plugin. And it's also possible to deploy to non-EVM chain like Near by using the plugin Code by Well Done. For each of them, the process is the same. Search for the relevant plugin, activate it, create your smart contract with the proper file extension, and compile with the plugin of the language. Now you know how to use smart contract languages other than Solidity in Remixd.
In this video, I will show you how to do static analysis with Remixd. For this example, we are going to use this smart contract, which contains a few issues. The first step is to activate the static analysis plugin. Go to the plugin menu, search for static analysis, and activate the plugin. The next step is to compile the smart contract. Go to the Compile tab, click on Compile or use the shortcut Ctrl+S. Then start the static analysis with this button. Alternatively, you can also start the static analysis in the static analysis plugin. After you click on this button, you will see this screen. You can select which tools to use for this analysis. This is the built-in static analysis tool of Remixd. This is a Solidity linter, and this is another static analysis tool. Please note that to activate Slither, you need to first connect Remixd to the local file system by using Remixd. Please refer to the video on Remixd for how to do that. Slither takes a bit longer to return the results than the Remixd analysis or Sol hint. Once you have configured this analysis, click on this button, and you will see below the result sorted by category. Warnings are in orange and errors are in red. If you click on one of the error cards, it will highlight the targeted code in the editor. Now you know how to do static analysis with Remixd. In this video, I will show you how to verify a deployed smart contract on Etherscan directly from Remixd. For this demonstration, we will verify a smart contract on the Sepolia test network. The same procedure can be used for any other network. This is the smart contract we will verify. It's already deployed on the Sepolia testnet. Before going to the next step, make sure that your smart contract is already deployed on a public network, otherwise you won't be able to verify it. Next, we will need to activate the contract verification plugin. Go to the plugin manager by clicking on the icon on the left sidebar. This is where you'll find all the available plugins for Remixd. In the plugin manager, type verification into the search bar. You should see the contract verification plugin appear in the result. Click activate to add it to your plugins. Now the contract verification plugin is active and ready to use. You'll find it in the left sidebar with this icon. Let's open the verification plugin. There are 4 tabs in this plugin: Verify, Receipt, Lookup, and Settings. The plugin can verify with Sourcify, Etherscan, BlockScat, and RightScan. Choose the chain of the contract you want to verify. For this tutorial, we're using Sepolia, so select Sepolia from the network options. To verify with Etherscan, you'll need to input your Etherscan API key in the plugin setting tab. For that, create a free account on Etherscan and copy your API key. Next, you'll need to provide some basic details about the contract. Enter the contract address, which you can find in the deployments detail if you did the deployment from Remixd. After, choose the contract name that you used in Remixd. Next, pick the verification tools you want to use. You can pick one or several. Now you're ready to verify. Just click on Verify. Under the hood, Remixd will verify your contract with the verification APIs of the selected services. Next, in the Receipts menu, you will be able to check that the verification was successful. For each verification attempt, you will see an entry. Expand this entry, and if the verification was successful, you will see a check mark here. If it didn't work, make sure that you didn't forget to deploy the smart contract first. Also, make sure that the address and the contract names are correct and try again. Next, you can check the contract page on Etherscan. Click on this icon and it will take you to the contract page of Etherscan. You can see the code of the smart contract, which shows that it was successfully verified. If you scroll up, you will see the read and the write tabs, which allow you to interact with your smart contracts. Back in Remixd, go to the Lookup tab, and for this simple example, I'll paste the address of the contract we just verified. The lookup will check the services for the verification status. It gives you the option to open the contract in Remixd. Now you know how to verify your smart contract from Remixd. That's it for this video.